Let's go through it. I don't have this one in slide form, so we can just scroll through it. So the idea of this notebook is just to play a bit around, like using this last time to just play a bit with Python. So I'm going to talk about, I'm going to use numpy and pandas, but I'm going also to use Scipy, and Scipy has lots of stuff. So Scipy has interpolation, integration, differential equations, and so on. And I will also talk about Matplotlib and about widgets. So widgets is a way of having interactive things. So so first of all, I mean, I don't know how. Again, if you tell me that like something is too simple or something, like let me know and we pass to the next topic. So again, easy plots. Imagine I have this function, okay? So this is scale factor as a function of redshift. It's very simple. A scale factor is the size of the observable universe, and redshift is the redshift of light. Okay, so you code this in a function. You create a linspace, so an array. You create another array in which you pass this to that. Okay, and that's it. Size 100. And the most simple function to plot is well, actually there are many libraries. I mean, Matplotlib is not the only one. I mean, there's other ones that contain Matplotlib and other things. Actually, there is Seaborn and Plotly and so on. But this one is pretty standard, and usually people always call PLT to this thing. There is other stuff. I mean, there is patches, geometrical figures, whatever. I mean, it's very big. So the most simple thing is to do plot of X and Y. That's it. And you can also start formatting things much nicer. So for example, you can add a formatter in this way. So first element is the marker, second element is the line style, and third element is the color. So you can have, for example, O for circles, dash dot for dash dot dash lines, R for red. The documentation contains all this. Okay, so of course there is no time to go through all of this. But for example, to plot these kind of functions, which are varying sometimes very smoothly, it's sometimes nice to use log. So for example, here you can use log. You can also use semi-log x, semi-log y. So if you want logarithmic on the y and the x, here I'm using dash dot, red, and a label. And notice that you can use LaTeX, okay, out of the box. You can put a title, you can put a legend. All right, so very easy. Again, if you have already seen this, let me know, and we can. Okay. So now let's go to some example, right? So you have this cosmic pi, right? And you have the Hubble function, which is basically the speed of expansion of the universe divided by the relative size of the universe. And we know that there is 70% dark energy, 25% dark matter. Oh, God. I guess this opened the same notebook again. And basically the speed of the universe is controlled by this equation in a specific model. And there are some parameters. There is the redshift. So this is the quantity of dark matter. This is the quantity of baryons, so normal matter, and so on. Okay. And if the universe is flat, and by the way, there was some recent articles and lots of media saying that the universe is not flat, but I mean, I think that was an exaggerated claim. But if the universe is flat, all these numbers here, together with omega lambda, which is the cosmological constant, should add to 1. So omega lambda plus this plus this plus this is 1. Okay. So if you want a flat universe, you can code this constraint. I'm just coding, like saying, okay, omega lambda is 1 minus everything else, okay? And I have a function that, again, we're not here, like, it's not about how to program in Python, it's more for what comes next. So I just have a function here that gets a dictionary and returns the value of those parameters with a getter function. If it doesn't find the parameter, he returns the Planck 2018 values. And okay, that's it. So for example, here I can say cosmological parameters and it returns Planck, okay? Or I can say cosmological parameters which, and it returns omega m, okay? It's just a way of doing this. I mean, you can do, I think it would be more elegant to do like a proper class, but for these examples, it's not needed. And then you just code the Hubble function. And I basically say cosmological parameters. I pass some parameters from dictionary and I return these parameters, and I pass them to the Hubble function that we saw above together with the redshift, and I return h of set. Okay, so you can see that Hubble today, h of set equals 0 is the h naught. So the famous h naught, which is now in tension with everyone. And if I pass some other h naught, 73, I get that as h naught. Okay, that's clear. Okay, so I might define my cosmology, right? And now the first exercise is to plot that. So let's go all the way. So this is a guided exercise, but since we don't want to spend too much time, let's go right away to the solution. So what I'm doing here is I'm just generalizing a bit this function above. So omega of set is basically defined as h naught squared times this, where p is an exponent, 3 for matter, 4 for radiation, and 0 for cosmological constant. So I can write this function. And then I can plot this in a nice way. So that's the exercise, but like the result of the exercise is this. So what I just want to show you here is a couple of things. If you want to know how to use Matplotlib, like do the exercise. But first of all, subplots, okay? Notice that I have 4 panels. So this is done in many different ways, but one of the nicest ways is to define it here. So you want an array of 2 by 2 subplots, so it's a matrix. You want all of them to share the same y-axis because it's the same quantity, and also to share the same x-axis because you have the same redshift in all of them.